All right, welcome back. This is part 2 of lesson 3.4. We're continuing with some more examples. So it says find the linear equation for the situation, graph it, and answer the question. So pedicure charges $20 to wash your dog and $40 for a trim. They need to make exactly $1,000 this week. What mix of washes and trims gets them their number? Okay, so let's detail what these different variables mean. Well, first, we want to know what is X, okay? So we're going to call X a wash, which they charge $20 for, and Y is going to be equal to a trim, which they charge $40 for. So this is where we want to actually use the standard form of the equation, because we know that $20 times X plus $40 times Y, so the number of washes, the number of trims, we want to know when it would equal 1,000, because we want to know how many of these do we need to get to $1,000. We can start to rearrange this equation to get it into slope-intercept form. So we can move the 20x by subtracting from both sides, so that means we've got 40y is equal to negative 2x plus 1,000. Okay, and then we can divide both sides by 40, and so now we know that y is going to equal negative 1/2 x plus 25. Okay, so we know that when there's 0 trims, or I'm sorry, when there's 0 washes, we would need 25 trims. That's one combination. Because again, we know that y is a trim. And what's 25? 25 is the y-intercept. So we know that that's going to be a y value. So our question here is, if they did 10 washes, how many trims would they need to do to hit the $1,000? So to solve that, we can simply take y equals, and we can take our negative 1/2, and we can put 10 washes in there. Okay, plus 25, and we can find out how many trims we would really need, and y would equal 20 trims. Okay. Now also we want to be able to graph this relationship. So where would we start? Well, if we go up, let's see, we'll just go somewhere up here, and we could say that this is 25. Why is that 25? Because it's the y-intercept, and we know that it's going to be decreasing. Okay, it's very, very basic. These are trims, these are washes. All right. All right, the next example says, find and solve the linear equations for the situation. So Susan wants to hire a babysitter for this weekend for her 3 children. She has 2 choices. Babysitter, sorry about that. Babysitter A charges $8 per child and $6 per hour. Babysitter B charges $12 per child and $3 per hour. When will they charge the same amount of money? So I asked, what is the thing that varies in this situation? Number of children or hours? Well, that's easy. It's going to be the number of hours. Children are the same. She's got 3 children. So how can we write an equation for babysitter A, money versus the hours? And then how can we write an equation for babysitter B, money versus hours? Again, standard form is going to work quite well here. For babysitter A, we can take the rate of $8 per child, which we know there's 3, so that's going to be X, plus what they charge, $6 per hour, and that's y. So there's an equation. For babysitter B, it's going to be $12 per child. So we've got the 3 children plus $3 per hour. So there's our 2 equations. So in part D it says, how do we model the question? When will they charge the same amount? And what is the same? Okay. So how are we going to figure that out? How are we going to figure out when they charge the same amount? Well, that's very simple. Set these 2 equations equal to each other. So I'm going to multiply these. 8 times 3, that's 24. So if I have 24 plus 6y, I'm going to set that equal to 12 plus 3 plus 3y, which is going to be 36. 36 plus 3y. Okay? And if I do that, I can go through and I can solve for y. So what I'm going to do, I'm going to subtract 24 from both sides, and then I'm going to subtract 3y from both sides, and so I'll get 3y is equal to 12. Divide both sides by 3. Y equals 4 hours. So they are going to be exactly the same at 4 hours, whether you go with babysitter A or babysitter B. So then part E, how do we solve for the number of hours when they both cost the same amount? How many hours? Again, we just did that. That's going to be 4 hours. Okay? And then looking at this, we want to figure out which line represents babysitter A, which is babysitter B. To do that, all we really need to do is look at these different y-intercept rates. Babysitter B charges more initially. Babysitter A charges less initially. So if we're down where we have 0 children, babysitter B would initially be more money because they charge $12 per kid, okay, versus babysitter A. So they're going to be more initially, okay. How does the intersection relate to your answer for E? Well, it's pretty simple. At 4 hours, what's it going to cost? So we go to here where it intersects, and it's hard to see on this graph. You guys will be able to tell better on your printed copy. We come over here, it's between 40 to 45, so we're looking at about $42. So there are times when you do need to be able to estimate from a graph, and that's pretty close. So that's pretty good. All right, that concludes the information for part 2 of lesson 3.4.